Hello, my name is Imran Aslam. Today I am going to give a demonstration on centrifugal pump performance modeling application. First of all, I will describe the procedure of installation of this application on the computer from the setup file, and then later I will explain the main feature of this application. So let us start with first with the installation procedure. Now, if you already have downloaded this application setup file from my website www.petrosoft.com, then you can simply double click on this application setup file. The application utility will be launched on your computer. From the language setup, you can simply select the appropriate language and then press the OK button. It will take you to the license agreement window where you can select the I accept the agreement option, then press the next button. It will take you to the information window, then press the next button. Now it will take you to another window where it is asking you an option to create a desktop shortcut of this application. Now it is always good idea to create a desktop shortcut of this application so that you can run this application straight away from your computer anytime in the future from the desktop. So here I will just simply keep the check mark against the desktop shortcut icon and then press the next button. Now here it will take you to the final step of the installation where once you press the install button, the application will be installed on your computer within few seconds. Since I have already installed this video on my computer, I will not press the install button. Instead, I will simply cancel the installation utility wizard and get out of this procedure. Then I will go to my desktop where I have already created a desktop shortcut of the application. I will just double click on the desktop icon. The application will be launched on my computer instantly. Now this application centrifugal pump performance modeling is developed specifically to perform the calculation to develop the pump performance curve for basically this application can be used to design a brand new centrifugal pump, or this application can also be used to retrofit any pump, any centrifugal pump which may be lying in the workshop or anywhere in the warehouse, which vendors manufacturing data or performance curve is not available, and you wanted to retrofit this pump or use this pump on the site for a given service. So in both the condition, this application is a really helpful tool to generate the performance curve of any given centrifugal pump. Now let's look at the menu bar at the top. From the left hand side, you will see a file menu. Under the file menu, you will have three sub menu options. The first option here is the new option, which actually launch the new instance of the application. For example, if I have closed this application from this cancel button, then I can launch the new instance of the application from this new sub menu option. Further, the next option is the save button here, which actually help to save the PDF file of the results after once the calculation is done. I will show you later after when we run the calculation. Now the next option is the exit option, exit button that will close the application from the computer. Moving forward, next option is on the menu bar is the about option. Pressing on the about option, you can read the basic information of the application and the developer. Now the next available menu on the menu bar is the help menu, which once you press this help menu, it will open up the application manual which comes along with the application setup file. This is really a helpful tool, a helpful file where you can read in detail all the narrative and description along with the pictorial representation of each step and the input page and the output page, the results sections, each and everything, the utility, the unit of measure and all the basic information or the detailed information are provided in the manual for a future reference. Now again I will go back to the main application window and let's look at the main features of this application. On this application, you can see below the menu bar there are further multiple pages given. Each page contains some information. The very first page from the left hand side is an input page where you will provide the basic information regarding the pump that you are going to generate the performance curve for. All the basic information such as the pump suction hydraulics, discharge hydraulics, pump dimensions, impeller blade dimensions at the inlet of the eye, impeller blade dimension at the exit of the blade, and impeller blade angles. Also, there are three main types of pumps. Centrifugal pumps generally we see forward vane curved, backward vane curved, and radial vane curved. So any of these option can be selected from the option buttons below each figure. As you can see, by just simply clicking on the option, you can select the required the type of the pump impeller blade. Once all the information is provided in the input section, then simply by pressing the calculate button down below, the calculation will be done, and the message bar below the calculation group button turns green with the title or a caption says OK, which means that the calculations have been completely performed. The calculations have successfully done, no error messages were found. However, if any time during the input page the user provide any incorrect value or incorrect information in the required field, for example, if the user typed in the text value in the field where the numeric data is required, then on pressing the calculate button will actually stop the application, stop the program, and give the error message down below with a red background saying that there is some incorrect value has been punched into the required field. So the user then go back and revise the value with the correct and appropriate numeric figure, and then again press the calculate button. The calculations will be done. So this program will warn the user or stop the program before executing if there is any error found during the input section of the application. Now once the calculations are completed, now it is ready to look at the results that are generated or calculated based on the input data provided by the user. So the first result section or the page is the pump performance curve. Here on this tab or on this page, you can see the pump performance curve, and the other important curves are also calculated and generated and displayed on the graph. Going from left to right, you can see there are few curves. Number one is a theoretical performance curve, actual performance curve, total pump head, efficiency, power, operating point of the pump, and the required head at which the pump is supposed to be running. All these curves are generated simultaneously on the same graph for the quick analysis and comparison. However, the user can always have an option below in the graph selection tab over here, where upon selecting any of the required curve option, the user can visualize each curve independently. For example, by default the graph selection is selected for all the graph over here. If I select the next option, which is the pump head option, then I can see only the theoretical pump head and the performance curve of the actual head of the pump, along with the operating point which is shown as a red diamond on the curve over here. Now the next option is the system head, which is basically the system performance curve. This is the performance curve at which the pump is supposed to be running, or the required head where the pump required to achieve during the actual operation. And it also shows with a little blue triangle which is representing the required head on the system performance curve of your system at which for which the pump is going to be working on. Now the next option is the pump efficiency. The pump efficiency curve can be visualized by selecting the pump efficiency option. Similarly, the pump power option can be selected as well on this option window over here. Now you can press again the all graph option, where all the graphs are shown simultaneously together in one graph. Now moving to the next result page, which is the pump losses curve. Here actually, if you look at the pump curve, the pump head, here you can see the theoretical head is almost a linear or almost a straight line without any losses, and in actual world the pump performance curve or the head curve is always in a parabolic shape because of the losses in the pump that occur when it is running. So those losses are also calculated and represented by a graph or curves over here. So all the main pump losses such as the shock losses, impeller friction losses, volute friction losses, disc friction losses, recirculation losses, contraction losses and expansion losses, if there are all together shown on this page over here. Now moving to the next result page, which is the velocity triangle. This velocity triangle is basically the main calculation parameters of the impeller at which you can analyze the different velocities at the suction of the pump, basically at the eye of the pump impeller and at the exit of the pump impeller, and also the total pump head result section over here, which simply shows what is the static head it is going to be operating, what would be the pressure head, dynamic head, system head, operating flow, pump operating head, pump discharge pressure, and control valve dP minimum. Control valve dP minimum means that when I go back to this pump performance curve and select all, you can see that the required head with a little blue triangle is just below the operating point, which is represented with a red diamond. So there is always better to have some margin over here, which means that if there is any margin here, then it means that the pump is actually capable of producing the head greater than the required head where the pump is supposed to be working, so that we should always have a control valve or some kind of a pressure drop valve at the discharge line of the pump to compensate for that difference. That is why when you look at this velocity triangle page, result page, you can see the control valve minimum dP is also calculated, which tells you another important information, that a control valve may be required on the discharge of the pump, and it will be operating at around 1 psig differential pressure margin from between the pump discharge head and the flowing pressure on downstream of the valve. Now moving forward onto the pump losses, as we have shown, as I have shown the pump losses curve, all these results are tabulated in the form of a table for a minimum, between the minimum flow to the maximum flow condition. All the losses are shown over here in the tabulated form. Similarly, the pump curve data for a minimum flow to the maximum range of the flow is also tabulated in this table over here. Moving on to the efficiency and the power, again it is shown as a tabulated data in the table, in a separate table over here. And finally, a section is provided with the figures that actually shown the areas of calculation performed for the internals of the pump. All this information can be seen on this diagram over here. For example, if we look at this impeller shape, the velocity triangle that I explained earlier, the inlet velocity representing the inlet hydrodynamic of the fluid at the eye of the impeller blade or at the inlet of the impeller blade, and the outlet triangle represent the hydrodynamics of the fluid at the exit of the of the impeller plate. Similarly, the shock losses and the losses on the impeller and the actual performance curve are represented with the figure over here. So that's pretty much all about the information related to the results section and the input section. Now the other important feature of this application is that you can always print out the results in a PDF format. For example, if I go to the file section and press the save button here, then the results can be printed either through your attached printer or into the PDF format. So just for an instance, I will just print these results in the PDF format. I will press the print button, the results will be printed and shown in the PDF format, and I can save it on the desktop. So it is now printing. Now you can see the results are printed and I can see all the results. So total 10 number of page report is generated for the results of this application. We can go one by one to each page to see how the results are printed. If we found it okay, then we can go ahead and start another instance of application if required. Similar function can be performed from the print preview. Before printing the file, we can go to the print preview section to look at how the results will be shown on the PDF form or in the paper form. Then all the results can be seen. Similarly, with the print button, we can print this into a PDF file or save it or print it through the hard copy. Thank you very much. Hope you like the video. For more informative videos on my upcoming chemical engineering application, please visit my website and like my channel. Thank you very much. Bye bye.